For the supervised portion, we decided to use convolutional neural networks in order to predict whether or not someone has COVID based on a lung CT scan. When it came to data cleaning, we had it prepped to scale from 0 to 255, did a random shear of 0.2 and a random zoom of 0.2 in order to avoid some degree of overfitting when it came to training. In addition, we also used data augmentation with the image data generator class. In terms of splitting our data between training, validating, and testing, we had 70% for training, 20% for validation, and 10% for testing. In addition, we set the epochs to be programmed for 15, but the model itself stopped training in epochs if there is no major improvement in the model, so it ended early if there were only incremental arbitrary differences in loss. The current CNN model structure at the moment is a 2D convolution with max pooling, then another convolution with max pooling, and at last a third convolution with max pooling. Then the model flattens the images before it's fed into fully connected layers, i.e. neural networks, with dropout. On the fully connected layer portion of the model, we have two layers of neural networks with two different activation functions. The first layer uses the ReLU activation function, and the second layer uses the sigmoid activation function. When the model is compiled, we use the atom optimizer as well as use the binary cross entropy loss function. Currently, after we trained and tested the set, we found that we had a 84.36% accuracy with a 0.0471 loss, which is pretty good considering the overall set. One of the challenges that we encountered was trying to ensure that the model isn't overfitted, so we decided to utilize those methods mentioned before in order to solve some of those problems. Also, it doesn't account for horizontal or vertical shifting as well as flipping of images, so it's possible that the model was overfitted for the standardized position of the lung CT scans. We're currently looking into fine-tuning the model on a pre-trained architecture like ResNet 50 that may help with both overfitting as well as improving the accuracy, which is another challenge. Overall, we made great strides in predicting COVID from lung CT scans, and hopefully by the final project submission, our accuracy on the model will improve significantly.